You ever stop and wonder why some things seem to happen in a flash, while other things take, well, forever? It turns out there's this hidden world of chemical helpers just quietly controlling the speed of everything around us, and even inside of us. So today, we're going to dive into the really fascinating world of these hidden helpers, chemical catalysts.
Yeah, just think about it. On one hand, you've got a super slow, creeping reaction, like rust forming on a bike over months and months. And on the other hand, you have the instant whoosh of a match lighting up. I mean, they're both chemical reactions, but they're on completely different timelines. So what's the deal? What's controlling the pace here?
To really get what's controlling that pace, we've got to take a closer look at the world of reactions themselves. Explore what really separates the fast from the slow. Just imagine the possibilities for a second. What if we could take a reaction that's way too slow to be useful and just make it happen instantly? Or even just speed it up enough to make it practical? This question right here is at the very heart of so much of modern science and industry. And you know what? Being able to control reaction speed isn't just some hypothetical idea. The answer to that question lies in this incredibly powerful tool called the catalyst. So a catalyst, to put it simply, is a substance that just increases the rate of a chemical reaction. But here's the really cool part. It doesn't get used up in the process. It's like a chemical matchmaker. It does its job, gets the reaction going, and then it's ready to go again, totally unchanged. These three core properties are what give catalysts all their power. It's not just that they speed things up, it's that they do it without getting consumed. I mean, think about that for a second. Because they stay unchanged, a single catalyst molecule can do its job thousands, even millions of times. That reusability is what makes them so incredibly efficient and so valuable. Okay, but how do they actually pull this off? How do they speed things up without being changed themselves? Well, the secret is all about finding a clever energy shortcut. It turns out that every single chemical reaction, from lighting a match to digesting your lunch, needs a certain little jolt of energy to get going. You can think of it as an energy hill that you have to get over. Scientists call this hill activation energy. Now, without a catalyst, that energy hill can be huge. We're talking like trying to get to the other side of a massive mountain range by climbing straight up and over the tallest peak. It's going to take a lot of time and a ton of energy. And this is exactly what a catalyst does. It doesn't magically get rid of the mountain. Instead, it builds a tunnel straight through it. It provides a whole new pathway where the reactants can meet up under just the right conditions. This new path needs way less activation energy, so the reaction just happens much, much faster. Now, this whole energy shortcut idea isn't just some abstract theory in a textbook. It is happening all around us, and even inside us, every single second of every day. I mean, just check out this quote. In living things, catalysts are called enzymes, and they are absolutely essential for life. The difference they make is just staggering. We're talking about turning processes that would literally take years into something that happens in the blink of an eye. Seriously, right now, as you're listening to me, trillions of enzymes are hard at work inside you. These super specific biological catalysts are breaking down your food, building the proteins your body needs, and unlocking the energy in your cells. Without them, life as we know it would just stop. And it's not just in nature. Your car's catalytic converter, that's a perfect example of industrial catalysis. It uses a coating of precious metals like platinum to turn nasty, toxic pollutants from your exhaust into much safer stuff. It's a great example of what's called heterogeneous catalysis, where the catalyst, a solid, works on reactants that are in a different state, in this case, gases. Even your kitchen is basically a little chemistry lab. When you bake bread, the enzymes inside the yeast go to work, speeding up the breakdown of sugars in the flour and releasing carbon dioxide gas. And all those little gas bubbles getting trapped in the dough, that's what makes bread light and fluffy. So from our bodies to our cars to our kitchens, it's pretty clear these catalysts are literally everywhere. But let's zoom out for a second and look at the big picture. Why do they matter so much? All right, so let's just recap what makes them such a game changer. By lowering the energy needed for a reaction, they dramatically speed things up. This makes processes that were totally impractical suddenly possible. And since they are reusable, an incredibly small amount can have a massive impact, which cuts down on costs and waste and makes whole industries way more efficient. And their impact is just immense. It's estimated that catalysis is involved in making over 80% of all manufactured goods. It contributes to more than a third of the world's entire GDP. From making plastics and fuels, to cleaning up our environment, to developing new medicines,
Catalysts are truly a cornerstone of our modern world.
When you get right down to it, catalysts are the unsung heroes of the chemical world. They work tirelessly behind the scenes, making so many processes that we rely on every single day, not just possible, but actually practical and efficient.
So we've seen how enzymes work in our bodies. But let's take that a step further. I want you to really think about the incredibly complex, super fast, continuous chain of reactions that defines what it means to be alive. So I'll leave you with this question. Why would life itself be utterly, completely impossible without these tiny biological catalysts?